In our last video, I showed the design for the laser communicator that we are building. And, well, to say I made a mistake would be an understatement. I'm really surprised nobody caught me on this, but I haven't seen anything in the comments yet. I've seen some comments about some other things, but we'll discuss those at another time. But here is the mistake I made. So we start out with our microphone. We need a bias resistor because it is a condenser microphone. We put a capacitor to block DC from the next bias circuit over here, which we put a couple of equal resistors here so that it brings this point up to about 4.5 volts. We are starting with 9 volts on our power supply, actually using a 9-volt battery. Okay, so far so good. Now our signal goes to our operational amplifier. Draw that just a little further over this way. This resistor was about 500K. This one is about 10K, giving us a gain of 50. And then onto the laser module, possibly with a transistor in here to give us the current we need to actually run the laser diode. So I started to build a proof of concept because I don't want to make the next video while I'm actually building it. I want to make sure it works so that it goes together rather smoothly. So I start to build it up and I go here, okay, I got the resistor here. I think that's a 1K resistor. It seemed to work okay. And through a 1 microfarad capacitor. And here's our 4.5 volts here over to the op amp and O. Yes, major facepalm here. What do we have going here? We have plus 4.5 volts DC with a gain of about 50 DC gain. So what's the op amp going to do? Remember, an op amp is going to make the output voltage whatever it takes to make the two input voltages equal. So this has a gain of about 50 with 0 volts here. So to make this plus 4.5 volts, it's going to have to put somewhere around, oh gee, gain of 50, 100, off the top of my head, 50 times 4.5, I can't do the math in my head, let's just say 150 volts here. Well, that op amp is going to say, hey boss, I can't give you 150 volts. Best I can give you, I've got 9 to work with, best I'm going to give you is maybe around 8 volts. And it's going to sit there at 8 volts. So obviously this isn't going to work. So my thinking was correct in my basic concept, but I fell apart here. Just basic op amp theory, I mean very, very basic op amp theory, I just fell apart right here. So what are we trying to do? We are trying to maintain this 4.5 volts on through the circuit all the way down to our laser diode when there is no signal coming in off the microphone. Then when that signal comes in, we want this voltage to go up and down and those variations to be amplified on the end. So how are we going to get this 4.5 volts to remain the same all the way to this point? And actually this should be over to the laser diode there. So what are we going to do? Well, first of all, we need to make this voltage here 4.5 volts. We're going to need some kind of a 4.5 volt reference. Can you read that? Try this here. 4.5 volt reference right here. And if I need a low impedance there, such as a really decent ground, I do have a spare op amp. I'm going to use an LM358 here, so that's a package with 2 op amps. So if I need to, I can actually put a voltage reference over here using a voltage divider just like this one, make another one of these, feed that into the other op amp and give me a 4.5 volt reference here, but I might get away with just another voltage divider. Let's get that out of the way here. 2 equal resistors, 10K or whatever, and Might get away with that. Can we use that as a ground? Well, remember, a ground has two purposes. It's our zero reference. Well, our zero reference is this ground here. 0 volt reference is right here. But basically, our AC voltage reference will be at 4.5 volts. That's the center of our AC. We're at 4.5 volts DC, and our AC is on top of it. So that would be our reference for our AC. And the other thing about a ground is that it must be able to accept any current, either sinking, current going into it, or current coming out to it, sourcing or sinking, without that voltage changing. Well, the currents in here are going to be very, very low, and I don't think that this voltage will change much, so we might get away with just another voltage divider here. If we do get significant voltage changes with the tiny currents going through, we could either decrease the size of these resistors to reduce that, or possibly, like I said before, run this to the other op amp to basically do this, run that voltage down to here, make a voltage follower, and run that back up to here. Oops, sorry, up to here. And yeah, it's getting a little cluttered here, but basically we need to have a 4.5 volt reference at this point here, whether we can get away with a voltage divider or have to use the op amp to get the low impedance, so that as this sources and sinks current, that voltage does not change. So that's what we're going to have to do. We'll do that as we build it. We'll try this one first. So let's simplify the circuit, show you what we're going to build, starting with the microphone, its bias resistor, capacitor, voltage divider here to give us our 4.5 volts to make this 10K and 10K, so we don't get too much current through there. We're running this on 9-volt battery. We want to keep our currents as small as possible. And this will run over to our operational amplifier. That will run, if we can get away with it, to another voltage divider here to give us our 4.5 volts. That will run through our transistor to our laser diode, I missed that by a country mile. There we go. And of course this will actually go right there because we want to monitor the voltage across the laser diode. So here is the modified circuit. So we'll just run this back to the 4.5 volt reference here and see if that works as a artificial ground for the AC or not. If it doesn't, we may have to add the other op amp. Another approach to this would be to turn this into an inverting amplifier, which might actually be a little simpler. We might end up doing that instead. Let's put the op amp here. It's getting sloppy. Here we go. Clean our op amp and run this to our 4.5 volt reference, and then run this to our input. I'm getting sloppier by the minute. And 10K, 10K. So we have our reference here, and then run this up to here. And once again, this goes over to the laser diode. And again, of course, make this right. So this would be doing the same thing with an inverting amplifier. And just looking at it intuitively, I think this might be a little better because we don't have any currents flowing over here to complicate using this as my reference point. So much more likely to get away with not having to add the other op amps. So this looks like probably a better design. Use the inverting amplifier instead of the non-inverting amplifier. So that's our new design that we will build. And yes, I have built a proof of concept. It does work, has some complications that we will solve when we build the real circuit, but that's our basic design right there. Of course, we're going to have to do the same thing with our receiver because I made exactly the same mistake on the receiving end. So the redesign of the receiver will be something like this. There is our photodiode, our 1K resistor, 9 volts. This goes to our capacitor, our voltage divider to bring us up to 4.5 volts. Now once again I made exactly the same mistake, so we're going to have exactly the same solution over here. I think we will use the inverting amplifier. So let's draw our op amp. So go to our other voltage divider. And our input. We haven't figured out what the gain is going to be here yet. This runs to our power amplifier. And to our speaker over here. And of course, this actually will run to that point right there. So there's the redesign. Once again, we don't know what the gain is going to need to be here because we don't know what we need to drive the speaker. But the redesign is we do turn this into an inverting amplifier and run our non-inverting input to a voltage reference, and I think, well, like I said, we'll be a lot less likely to need to use the second op amp as a reference there. So there's the redesign, and in the next video, I promise this time, we're going to actually start building this communicator. If you found this video useful and informative, please give me a thumbs up down below. It really helps the channel. And subscribe because that not only informs you when I put new videos up, but it really helps the channel also. And a big thank you to my patrons at Patreon. I could not make these videos without your support. If you want to help me put these videos online and keep real vocational education free at vocademy.net, you can go to patreon.com/join/vocademy and pledge your support. And again, a big thank you to my patrons who make this possible, and a big thank you to everyone for watching.